Hello, everybody. We're going to be continuing on with the nervous system, discussing some applications towards the nervous system, focusing in on two primary applications of sleep and addiction. We're going to start off with sleep. Sleep is defined as the state of unconsciousness from which a person can be aroused. If you remember back from when we were looking at the parts of the brain, there was one part in particular that was responsible for arousal and sleep. I want you to right now write down what that part of the brain was. And I want you to think about that throughout this presentation. Additionally, with sleep, the brain is more responsive to internal stimuli than external. Sleep is necessary for survival, and losing sleep can take years off of your life, impair memory and physical performance, reduce your ability to do math calculations, cause hallucinations and mood swings, and much more. Sleep is broken down into stages. There are two primary stages, NREM and REM, non-rapid eye movement and rapid eye movement. One cycle takes about an hour and a half, and people average about 8 hours of sleep a night. One night's sleep is divided into 3 equal time periods, even though it's 4 here. Meaning the stages, and then you have the rapid eye movement sleep. But you have stage 1, which is light sleep, stage 2, which is the barrier, not the barrier, but the bridge between light sleep and deep sleep, and then you have stages 3 and 4, which is deep sleep, followed by rapid eye movement sleep. Non-rapid eye movement sleep starts with stage 1, which is light sleep, which is the transition between wakefulness and sleep. Your muscles begin to relax, and you can easily be awakened in this stage. It accounts for about 5 to 10% of sleep. Stage 2 occurs throughout the sleep period. It accounts for about 5 to 10% of sleep. Eye movement stops, and brain waves slow down. Stage 2, like I said earlier, is basically a continuation of stage 1. It's a little more intense, I guess would be a good way to put it, of stage 1. It's heavier sleep. Not quite full sleep, but it's heavier than the light sleep. Next, you have the deep sleep, which is in stages 3 and 4, which accounts for approximately 20% of sleep. In this stage, your slow brain waves appear with spurts of faster brain waves. Eye movement and muscle movement stop, and it's very difficult to wake somebody in this stage. If you are awakened in this stage, you will, in most cases, feel groggy or disoriented, meaning if you're woken up within your deep sleep stage, you're going to be a little grumpy and groggy and like, who am I, where am I type of scenario. In this stage, for younger kids especially, as they're developing their sleep patterns, bedwetting, sleepwalking, and night terrors occur. After the non-rapid eye movement sleep comes the rapid eye movement sleep, which accounts for about 20 to 25% of sleep. It occurs about 4 to 5 times during normal sleep periods, and it can be anywhere from 10 to 60 minutes. During this stage, the eyeballs move rapidly, hence the name rapid eye movement. Heart rate, not heat rate, and breathing become irregular. Blood pressure also rises. During REM, it occurs about 90 minutes, and muscles in the body are virtually paralyzed. This basically sums up the sleep part of the presentation, and I want you to keep this information handy because you're going to be writing a paper on sleep and whether or not school should be open later because of sleep, or to allow for more sleep. Now we're going to start talking about addiction, and we're going to just get a general view of addiction, but we are going to discuss it. Drugs have neurotransmitters called dopamine, and your brain reacts to the excessive dopamine levels by reducing the number of receptors for the neurotransmitter. Normal activities do not produce normal sensations when you have an excessive amount of dopamine, meaning what you would normally get pleasure from is not going to be a response to what normally causes it. So normal activities aren't going to produce the normal sensations that they would because the dopamine is interfering with this neurotransmission.
It's your brain. This is heroin. This is what happens to your brain after starting heroin. And this is what your body goes through. It's not over yet. This is what your family goes through. And your friends, and your money, and your job, and your self-respect, and your future. Any questions?
That was a little commercial on the brain on drugs. It was in the Super Bowl, one of the commercials in the Super Bowl a couple years back. But this video basically sums up what happens in the most simplest terms when your brain is on drugs. Your brain is basically destroyed, not completely destroyed, but it's destroyed when you're on drugs, and you can't think as well as you normally can. That's why it's called under the influence of drugs, as opposed to under the influence of yourself. You need to be above the influence of drugs, because when you're under the influence of drugs, judgment is impaired and you make bad decisions. Moving on from the nervous system, we're going to start talking briefly about the endocrine system, which, as I mentioned earlier in earlier presentations, how the endocrine system and the nervous system are very closely related in that they're both control systems. The endocrine system, however, is hormones, where the nervous system is primarily neurobiology and the brain, the spinal cord, nerves, etc. So now we're going to start talking about the endocrine system. Here's a list of the primary structures of it. I don't want you to write this whole list down, but I do want you to write down a few key points. I want you to write down hypothalamus, the pituitary gland, and then ovaries and testes. I do want you to know that there are different glands, such as the adrenal gland, thyroid gland, etc., but I do want you to know the hypothalamus because it is the part of the brain, and the pituitary gland because that one is a big gland in the endocrine system. Even if you just put glands, endocrine glands, we're going to get into different types of glands, endocrine versus exocrine, but I do want you to know the hypothalamus, ovaries and testes, and then glands. And then the pancreas. Know that one as well. The pancreas is primarily an insulin regulator, which an application of that would be in diabetes when you have bad insulin, not bad insulin, but you can't regulate insulin on your own. So know that there's glands, the pancreas, the hypothalamus, ovaries, and testes. Primary function of the endocrine system is growth, development, metabolism, and maintenance of homeostasis. It all relates back to homeostasis. This system is very similar to the nervous system in that it works to regulate homeostasis. So you could relate feedback loops to the endocrine system and the endocrinology. In anatomy and physiology, if you decide to take that in the future, you will apply the endocrine system in different diseases of the endocrine system and different responses and stimuli of the endocrine system to a homeostasis feedback loop. But I just want you guys to know that it's responsible for growth, development, metabolism, and homeostatic maintenance, homeostasis maintenance. What is a hormone? I've been talking about hormones a lot in this presentation, but hormones are chemical messengers that travel through the blood and affect cells in other parts of the body. So just know that they are chemical messengers, that they travel through the blood to affect cells. Alright, now there are different types of glands. You have exocrine and endocrine. They're very similar, but I want you to know the key differences. Exocrine glands release secretions through ducts, tube-like structures, where endocrine release into the blood. Exocrine glands travel out of the body or into the digestive tract, where endocrine glands travel throughout the body to the location of major endocrine glands. Exocrine release sweat, tears, and digestive enzymes. And endocrine glands release to glands, bones, fat tissue, the heart, and the small intestine, for example. I'll keep this slide up for a couple more seconds so you guys can get all the information about the different types of glands. We're not going to be focusing in on the endocrine system. I just want you to know how it relates to the nervous system and how they're both control systems. On our little assessment for this unit, you're not going to be tested on the endocrine system, but you may be given little quizzes in class on this information. That basically sums up the applications and endocrine system, so I hope that you understand the relationship between the endocrine system and the nervous system and are more clear on some applications of the nervous system. Thank you. Have a good day.